Hello everyone, and welcome to your video on composite functions. So well, here, let's just start with some functions. Let's say that you know that function f of x equals x plus 2. And let's also say that you know that g of x equals 3x plus 4, or minus 4. And just to remind you, when I use the word function, you can think of them as lines. So we have one line on our graph, which is x plus 2, and we have another line in our graph, which is 3x minus 4, right? That's all we're talking about. These are two different lines on the graph. And we have learned already that we can add these functions, right? We could have f plus g of x, which would be f of x, which is x plus 2, plus g of x, which is 3x minus 4. And then we could simplify this into 4x minus 2, right? Are we cool with that? So we can add these two functions. We could also subtract the two functions. We could do f minus g of x. So that would be f of x, x plus 2, minus everything in g, which is 3x minus 4. Now this gets a little trickier because we have to distribute this negative sign over everything, but still, we've done this enough that this is starting to look pretty decent to us, and we can reduce this into negative 2x plus 6, right? Okay, so we've learned how to add functions, and we've learned how to subtract functions. What we're going to do today is we're going to learn about composite functions. That is taking one function and putting it inside of another function. Now, there is no real practical application for this at this point in your mathematical career. It's just kind of cool. So please don't say to me, when are we ever going to use this? Because the answer is going to be totally unsatisfying. The answer is going to be totally academic. It's going to be, well, when you take a calculus class, then you will need to know how to do this. And I know that that is a lame answer, and yet that is the answer that I'm going to go with. So let's just refresh our memories. I'm just going to rewrite them again. We know that f of x is x plus 2, and we know that g of x is 3x minus 4. So what we want to do is we want to put one function inside the other function. So we're going to take the f function, and we're going to put the g function inside of it, and that's how we would write it. We would say it f of g of x. F of g of x. All right, so think about this. Let's take our x function. That's x plus 2. And instead of the x, we're going to put in our g function. So that's going to be 3x minus 4. That's what gets replaced. So 3x minus 4, the g function goes in place of the x inside of the x function plus 2. So that gives us 3x minus 2. Okay, that's f of g of x. But wait, it gets more exciting because we could also calculate g of f of x. In other words, let's put the f function inside of the g function. Okay, well, what is the g function? Well, we know that g of x equals 3x minus 4. Whenever we see the x, we're going to put the f inside of it. So this is going to be g of f of x with the f inside the g function is going to be 3, and then you put in the f, which is x plus 2, and then you finish it off, minus 4. So that's going to be 3x plus 6 minus 4 equals 3x plus 2. Notice that f of g of x is not the same thing as g of f of x. Here we get 3x minus 2, and here we get 3x plus 2. Now, no, it doesn't always work out so beautifully where it's the same numbers and it's just a different sign. Don't get all excited, right? It just happened to work out this way. All right, so that would be an example of taking a function and putting it inside another function. Let's do another example. Let's try this example. Let's say that I told you that f of x was x squared, and I told you that g of x is x minus 3. Okay, remember those are just two different lines on the same graph. And we want to put one of them inside the other. So I'm going to ask you to figure out f of g of x. So that's, we're going to take the g function and we're going to put it inside the f function. All right, so let's start by writing our f function, our big function. Our big function is x squared. So wherever I see the x, I'm going to write my g of x. So f of g of x, now I'm putting the g function inside the f function, which means I'm going to, wherever I see x, I'm going to substitute this. So that's going to be x minus 3 squared. See, I put the x minus 3 in instead of the x. Do you see what I'm doing there? All right, and then I have to work it all out. X minus 3 times x minus 3, right? Because that's what the squared means. So that's x squared minus 3x minus 3x plus 9. So x squared minus 6x plus 9. That is what f of g of x equals. Okay, let's do g of f of x. All right, so we're going to take our g function and we're going to put our f function inside of it. So our g function is x minus 3. Our g function with the f function inside of it is, every time I see the x, I'm going to put in the x function of x squared. So g of f of x is going to equal x squared minus 3. Oh, this is a much better example. Look at f of g of x is x squared minus 6x plus 9. G of f of x is x squared minus 3. There, they're not even close to each other. Okay, do you kind of understand what you're doing? So you have to kind of keep track of which one is going inside the other one. Okay, now, this can be written in a different way. So here we have f of g of x. I like this notation because this makes it easy for me to remember that g is going inside of the bigger f function. However, it can also be written like this. This is an F, this is not an O. This is a little tiny, it's kind of like a degree sign, you know, like if you were going to write that something was 7 degrees. It's like a degree sign, except it goes right in the middle of the line. So it would be like that. And it's not filled in like a period or a time sign. It's open. It's called a ring operator. Ring operator. Okay, so this is how you would write it. F of g of x could be also written like this. F of g of x. You read it the same, you write it differently. So over here, this would be written g of f of x. Okay, those mean the exact same thing. You can use whichever one you want when you're writing it. You can also see both of them on tests. Okay. Let's do one more example. Let's say that we know that f of x, we're going to keep this nice and easy, is 4x, and we know that g of x is 2x plus 3. Okay? Here's what I'm going to ask you this time. I'm going to ask you to figure out f of g of 2. Whoa! F of g of 2. Okay, so the first thing that I do, wait, I get a different color for you. The first thing that I do is I rewrite it, because I don't like ring operators as much. I like this. So I'm going to rewrite it like that. That way I'm reminding myself that the g function is going to go inside the f function. Okay, but I want to do it to 2, so this is actually going to be a 2. Okay? All right, so since I've written it this way, it's easy for me to see that first I'm going to calculate g of 2, and then I'm going to stick that answer inside of f. What? Yeah, here I'll show you. So here's g of 2. That would be 2 times 2 plus 3, right? I'm just sticking in the 2 in for the x. So that's going to give me 4 plus 3, which is 7. Okay, so g of 2 is 7. Then I'm going to take this 7 and I'm going to put it inside my f function. So f of x, or it would actually be f of 7. I'm going to put the 7 inside my f function, will be 4 times 7, which is 28. So 28 is my final answer for what f of g of 2 is. Here's a different way that you can do it. If you don't like that way, which you might not like that way, you could do this. You could say, okay, first I'm going to figure out what f of g of x is. And so that's going to be, I'm going to write f of x, which is 4x, but instead of the x, I'm going to put 2x plus 3, right? So I put my g function inside of my f function. And then I'm going to simplify. 8x plus 12, right? Now I can calculate this by 2. F of g of 2 is going to be 8 times 2 plus 12, which is 16 plus 12, which is 28. See, you get the same answer either way. So here, I calculated g of 2, and then I put that answer in my f function. Here, I first combined the 2, just using x as my variable, right? I combined the 2, and then I stuck in the 2 number in order to get an actual answer. Does that make sense? We'll do one more. I know, I said the last one was the last one, but I lied. We'll stick with the same functions though, okay? So f of x is still 4x, and g of x will still be 2x plus 3. But this time, what I want us to figure out is I want to figure out g of f of 5. G of f of 5. So now you should really pause the video and see if you can do it yourself. Okay, let's pretend like you paused the video, and we're going to figure this out. So what I'm going to do here is I'm going to remind myself that really I'm talking about this. I'm talking about putting the f function inside the g function. So since I want to know f of 5, I will calculate f of 5 first, which will be 4 times 5, which is 20. I will then take this number and I will put it in my g function. So g of 20 now, because this goes in my g function, will be 2 equals 2 times 20 plus 3. So that's 40 plus 3, which is 43. Okay? So that's how I could do it. G of f of 5. I first calculate f of 5, I get 20. I then take 20 and I put it in my g function. And I know that I did it right because I want my f inside of my g. My f inside of my g. As an alternative, I could have done it like this. If I were calculating g of f of x, I would say, okay, so that's going to be g of f of x. So f is going to be inside of g. So that's going to be 2 times 4x plus 3. So that's going to be 8x plus 3. So now I've combined my two formulas. Now I can calculate this with 5. So 8 times 5 plus 3 equals 40 plus 3, which is 43. So you see I get the same answer. So you can either combine your two functions first and then plug in the number, or you can plug the number into the first function and then plug that answer into the second function. Either way gets you to the same spot.